Hello, today I'm going over properties of matter. So we're just looking at some basic stuff here as we introduce some ideas of chemistry. And so this is some different ways that we can describe matter or think about matter. Matter is anything that has mass and takes up space. And these characteristics can be measured through extensive properties. You can see on this side, it gives extensive properties. And if you look, these are things that we can measure, right? Weight, length, volume, entropy. We'll get to the intensive properties in a moment. The mass of an object shows how much matter it contains, while the volume measures how much space it occupies. For example, a large bowling ball has more mass and volume than a smaller one used in a different game. Extensive properties such as mass and volume depend on the amount of matter in a sample and change when the quantity of matter changes. This is pretty obvious stuff, right? We still have to spell it out, but it's pretty obvious. If I have a ball of clay and I add more clay to it, well, now it has more mass and takes up more space. All right, let's get down here. Intensive properties. Intensive properties describe the type of matter, not the amount. These properties remain the same no matter how large or small the sample is. So here's some examples, right? Let's look at the boiling point. Well, the boiling point of water is the same whether I'm talking about a drop of water or 15 gallons of water. That's gonna stay the same. If I make a sample of seawater, that concentration of salts is going to be the same, even if I have bigger or smaller volumes of that. For example, a bowling ball's hardness affects how it rolls. Harder balls tend to stay straight, while softer ones can curve. Hardness is an intensive property because it depends on what the object is made of, not how much of it there is. Oh, and that's another important thing. These will differ between different types of matter, right? The boiling point for alcohol is different than the boiling point for water. All right. A substance is a type of matter that has a uniform and definite composition. And we've got some examples of substances over here. A good example would be something that you would find on the periodic table. Tin is an element you find on the periodic table. Gold and copper are examples of substances, meaning that every sample of each has the same composition and identical intensive properties. So they say gold, right? Gold is on the periodic table. Well, whether I'm talking about 1 gram or a kilogram of gold, it has those same properties. So this is a substance. Let's see. These properties do not change because the makeup of the substance stays the same. Therefore, every sample of pure gold or pure copper will behave the same way under the same conditions. And you can have things like compounds, like water, as long as the water was just water and had nothing else in it, and it's going to act the same way. It's going to have the same properties. All right, physical properties. Gold and copper share some traits, but differ in others, such as color, hardness, and conductivity. So again, they're comparing two different elements, and they both have different intensive properties, but their intensive properties stay the same for each element. Copper is harder and conducts heat and electricity better, while gold is softer and more malleable. These differences are examples of physical properties, characteristics that can be observed or measured without changing the substance's composition. So these are some examples, right? The density of a piece of iron is going to be the same no matter what the amount of iron is. Same thing with melting point, and metals do have melting points. Physical properties like melting and boiling points help scientists identify substances. For example, a liquid boiling at 100 degrees Celsius is water, while one boiling at 78 degrees Celsius is ethanol. So these are characteristics that can describe and categorize a certain substance. Matter commonly exists in three physical states: solid, liquid, and gas. So you've heard this before. This is definitely something you've seen. So let's look at a little bit more detail on these. And this probably is a refresher for you. Each state has unique characteristics that distinguish it from the others. A solid has a definite shape and volume because its particles are tightly packed and arranged in an orderly way. So here's a solid. It has a specific shape. My pencil has a specific shape. It's a solid, right? The particles are all packed together and they're not moving around. They're locked into place. Solids are almost incompressible, meaning you can't squeeze them into a much smaller volume, generally speaking. Expand only slightly when heated and do not change shape to fit their containers. So they will expand a little bit, like metal can expand if it's heated, but only a little bit. And if I put a solid into a glass, like a drinking glass, it doesn't change shape to the drinking glass. All right, now let's get into liquids and then gases. A liquid has a definite volume but takes the shape of its container because its particles are close together but can move freely. So we have our liquid here. The particles can move around, but they're still packed in pretty tight. But because they can move around, it'll take the shape of whatever container it's in. Liquids are almost incompressible, just like solids, right? You can't generally squeeze them a lot smaller because there's not a lot of free empty space. Expand slightly when heated, just like the solid, and flow easily. A gas, on the other hand, has neither a definite shape nor volume and expands to fill any container. So this is different. Liquid takes the shape of its container, but the gas will expand to fill that container. Like the liquid in this glass doesn't fill the top part of it, but the gas in the same glass will fill all parts of that container equally eventually. The term gas refers to substances that are naturally gaseous at room temperature, while vapor refers to gaseous states of substances that are usually liquids or solids, such as water vapor. Water vapor would normally be liquid at room temperature, but water vapor has gained enough energy so it has become a gas. Okay, last one here. A physical change occurs when some properties of a material change, but its composition stays the same. So we've got examples down here. If I take a piece of wood and I break that wood apart, well, it's still wood. It's just smaller pieces, but it's still the same thing. For example, gallium metal melts at 30 degrees Celsius, and heat from a person's hand can melt it without changing what it is made of. When gallium melts, it changes shape and begins to flow, but it remains the same substance. It's still gallium, and it still has the same properties of gallium. Melting, freezing, boiling, and condensing are all examples of physical changes. And you've got some other ones here. Again, you're changing it, but not the substance of it. That'll happen with chemical changes, which we'll get to another time. Physical changes can be classified as reversible or irreversible. Reversible changes can be undone, such as when melted gallium cools and becomes solid again, or if I melt ice and then refreeze it. All changes that involve the shift from one state of matter to another are reversible. Irreversible physical changes, like cutting hair, filing nails, or cracking an egg, this one's a good one, cannot be undone and permanently alter the material's form. So it's still an egg, but you can't get it back into the uncracked egg, right? That process is done. It can't be reversed and go the other direction. Okay, I hope this helps. If you have any questions, please let me know.